Our next speaker is Jay Scrivener, who's Manager of Integrity Management and GIS at Boardwalk Pipeline Partners.
Thank you. Want to express my appreciation for PHMSA for giving Boardwalk this opportunity to talk about some recent improvements that we've made to our risk modeling approach. Real quick, for those of you who hadn't heard of Boardwalk, just a quick plug of kind of who we are. We're a master limited partnership that has about close to 15,000 miles of natural gas and natural gas liquids on our entire system. So, real quick, I'm going to try to kind of speed us along here because I hate being the guy between us and the impending lunch break. So, real quick, what were the goals for risk management? And I think we're going to see a lot of common themes on what Boardwalk tried to accomplish through our risk management approach. And one of the biggest ones is really getting a very broad deployment and access to risk information, to data, making sure that we can get access no matter where you are, at any time, anywhere, and get access to real-time approach or real-time access to that data. So we'll talk about that a little bit more. One of the biggest goals that we have, and I think you've heard a common theme for many people, is this is all data-driven. And quite honestly, we wanted to make sure that we had systems in place that we could engage our true SMEs, specifically our field operations personnel. These are the people in many cases that are gathering data, they're maintaining the data for us, and this data is really what's driving our risk evaluations in the end. So basically, have a process in place so that people can see the data, they can own it, they can solve it, and they can ultimately help drive for better risk results. So engaging operations management and field employees was a very big goal for us. And through that is the next bullet point is we're going to improve our data collection and management through that. If we could have a increased understanding of what is a risk program, we really felt like that would really help people that were collecting the data to understand, what if I'm filling this bellhole inspection report form out and I write down the wrong seam type? Does that really even matter? What could that possibly impact? So we embarked on an effort to try to simplify our risk program. I think we heard comments earlier about, the dangers of having a risk algorithm that is, while technically very competent, it could be very hard to understand what the impacts is of questionable data, poor data. So we strove to try to simplify the risk evaluations as much as we can so people understood kind of the cause and effect of the typical data. And then, of course, leverage technology. We're trying to implement solutions that are very commercially available, kind of off the shelf in some cases. And some, like our risk model itself, is very customized to our system. So we'll talk about that in a little bit more detail also. Before we kind of started this effort, I'm sure this is a foreign concept to many operators here, but we basically had completely disparate different databases that we used to maintain this GIS data. And across all of our operating units, they were different. So one of the first things that we needed to do is get all that data in a common location, a common format, so that we can analyze it and maintain it more easily. So we chose a Esri pod spatial model to put all of our company data in to run risk analysis on. So we run standard off-the-shelf Esri based GIS software to do all of our evaluations and calculations straight on this information that's in the GIS system. And of course, use those same tools to maintain pipeline attribute information, basically any other variables that are needed to do an effective risk evaluation. We also put an infrastructure in place that kind of modernized how we were storing this information. So we implemented a couple different cloud environments through an Amazon EC2 cloud environment, and also implemented another cloud environment through Google to allow kind of real-time access to visualize and access this information. Other common tools, we enhanced our risk evaluations to include things like one-call records. And that basically allowed us to enhance some of our risk evaluations above and beyond what we were normally doing. And finally, I alluded to this earlier, we tried to implement and we did implement a simplified risk model. Some of you might have heard of the model before, but we very simply call it a DRIP model, which could be questionable to call a risk model something that like a DRIP. But basically it stands for drivers, resistors, indicator, and preventers. And this is just a visual concept of trying to understand how a particular piece of information impacts our overall risk evaluations. Once again, our goal was to have a simplified model in place to engage our field operations people to help drive better data to get better risk results out of that. One of the biggest things that really allowed this to happen, and I apologize, I know it can be challenging to read, but basically what enables us to get this real-time access to information is basically this central data model, and you can see that in the middle of the screen. But basically, it gives us a common location to manage all the information that impacts risk, whether we're managing it natively in the ESRI spatial model, or if we're bringing in other system data sources like Maximo, for example, or CPDM for corrosion information. Basically, it still gives us a common spatial referencing system to access and maintain the information that ultimately will feed out to other tools to be able to view and access that information in the field in real time. So, as I've mentioned, we use our GIS system to store all the information that's needed for risk. So we do all of our analysis directly inside our Esri GIS environment. There's no kind of ETL process that's going on where we're extracting, transforming, and loading. For the most part, we run our evaluations directly on the information that's in GIS, and the results from those risk evaluations are stored directly back in GIS. So if you're wanting to easily access and view that information, there's not a separate risk database, if you will. We keep all the information inside our PODS database. And because of the technology solution that we've implemented to run risk natively in it, we have kind of all open access to any other data sources. I mentioned just a few here: Maximo, RexTag, FEMA data. Basically, we have one environment that we have full control over to store any of the information needed to make these risk evaluations. And we'll talk about that real quickly. And this slide here, I'm just is pretty much reiterating what we've said many other times. Is basically just knowing that relative risk is often used when a study involves comparing the likelihood or chance of event occurring between two groups. The relative risk is considered a descriptive statistic, not an inferential statistic, as it does not determine statistical significance. So once again, relative risk ranking. This is still the concept that we're still implementing today, knowing that as we get better data, we're going to evolve our model into something much more similar to a probabilistic model. So let's talk about the DRIP model itself. Once again, this is just a construct, if you will, to be able to understand how a particular piece of data impacts a risk evaluation. So first, the concept of drivers. These are basically pieces of data, and I'll give you some real-world examples about how actual pipeline data fits into these categories. But basically, a driver is a piece of data that provides direct causal information about a specific failure or consequence component. A resistor is data that indicates a potential resistance to a failure or component. An indicator would be a piece of data that provides an indication of a particular failure. And then finally, a preventer is data that would indicate actions taken to prevent the occurrence of a failure. So that's all nice and neat, but let's see how it actually relates to real pipeline data. So, example here for drivers and indicators. These are basically, for a driver example, is an easy, and let's kind of think about this in the context of an external corrosion threat, one of the 9 core integrity threats. A driver piece of information would be basically the age of the pipe. So generally speaking, as you have older pipe, typically that's a driver to indicate a higher potential of having external corrosion related. An indicator example would be just kind of what you think if we have a leak history, and this could be many other types of pieces of information. It could be ILI anomalies that we found from an inline inspection. But as this particular example, we're going to use leak history. So knowing that, if we have an increasing history of leaks on the pipeline, the model really needs to take that in consideration in terms of having an elevated risk. Under the resistors and preventers, these are basically data elements, kind of just the opposite of drivers and indicators, where drivers and indicators can basically act to elevate your risk. Pieces of data that are considered resistors or preventers can act to lower the risk. So a couple of examples here, as in a resistor example, is your pipe coating type. Do you have good FB coated pipe, or is it all tape coated? Kind of score, you can act to reduce the score depending on the quality of that data or the type of data. A preventer example would be a hydrostatic testing history, knowing that if you put a particular pipeline through a robust hydrostatic testing process, that is going to act as a preventer to keeping the pipeline from failing. Once again, trying to categorize these pieces of risk information in such a way that it's easy to understand for a non-risk person to understand the impact to the risk algorithm. Once again, going back to the theme that we saw earlier of trying to engage our field operations people so that they have complete buy-in into the process. This is not some risk model that's ran from by a couple of people sitting back in an office environment. We have full engagement across our entire workforce to collect this data and manage it and understand what the impacts are. So real quick, I don't think this concept is going to be kind of new to anybody, but here's a kind of a hypothetical application of how these pieces of information would impact risk. So we start off with kind of a blank pipeline right away, if you will, and looking at this in the context of external corrosion, we look to see for each of these D, R, I, and P indicators that we have. So once again, we kind of start off with pipe age being a driver. So we're dynamically segmenting our pipe, if you will, for this one particular thread and these very specific pieces of information. Here's how it kind of in the traditional, red, yellow, green kind of low or high risk all the way down to low risk. Here's kind of the impacts that as the algorithm's applied. Resistors, coating types, you might have sections of pipe that have really good coating, some might not. And that will impact the risk evaluations along the pipeline. And then finally, if you start having a robust leak history, that's going to obviously, in very specific dynamic segments, will elevate the leak history or elevate the risk. And then finally, preventers, if we do have a robust hydrostatic testing pressure history, that can kind of help give credit, if you will, on the total risk evaluation. So, as the algorithm steps down the entire pipeline system, considering the information and the data that's in our GIS system, we basically dynamic segment risk across the entire pipeline system for every inch of pipe that we have, obviously not just in HCAs. So one of the things that's kind of nice that we talked about data integration earlier and thread interactions. We have full control over the risk algorithm in-house. It runs natively in our Esri GIS environment. So if you will, there's not really an interaction with a CAN software algorithm. We directly control it ourselves programmatically. So if we need to change an interacting threat scenario or add one, we can literally make that change, and 30 minutes later, we can be running risk off of that. There's not a kind of process that we have to go to affect those enhancements to the algorithm. So that's one of the big advantages to this approach is you get rid of that ETL process, and you can natively customize the algorithm in a matter of what could be hours instead of what could take much longer with different approaches. So this is just a reiteration here that we do thread interactions straight into the risk evaluation process. So we do the typical scenarios. I give just a few examples here: external corrosion associated with low frequency ERW pipe, or existing external corrosion accelerated by third party damage. you can basically see, you know, Boardwalk has over a dozen different interacting scenarios that we look at right now to try to understand if we have certain threats that are present, what does that do to our overall risk evaluation process? So it'll drive, you know, as the risk scores get adjusted dynamically, it'll drive changes to our baseline assessment plan schedule. It'll drive potential changes to P&M measures, just as you would expect when these situations are present. In order to enable access to this risk information in such a way that you don't have to be a risk integrity engineer, we've implemented additional software that basically allows us to kind of allow a lay person, if you will, to be able to drive down into the risk results to see what is really truly driving. Why is a particular segment of pipe high risk, low risk? I apologize, we won't have time to get into details of it today, but basically we've implemented a web-based tool that allows you to simply just point and click and drill down into the source data that is driving, you know, particular risk scores without having to have any specific GIS knowledge. So we're really pleased with this one particular tool that we put in place. Along with that tool, we've also put tools in place to help understand risk as is involved with implementing P&M measures. I think we heard in a previous presentation that, you know, you really need to understand if a particular P&M measure is going to, what it's going to do to your risk. And we put the capabilities in everybody's hands to run our risk evaluation in real time to be able to understand if we did a pipe recoat, for example, or if we did a pipe replacement, if we did some type of improvement to a CP system, what is that really going to do to the risk scores? So we've got tools that we have in place so we can understand in real time what is the kind of the risk benefiting magnitude for doing a certain preventative mitigative activity. Once again, you don't have to know anything about the technical details about the risk algorithm or GIS. You have real simple tools that are point and click that can allow that real-time evaluation. And finally, kind of built on all that is basically a whole suite of software tools. This is not a plug for any one company, but it's basically just how we've built and put together a system to be able to manage and maintain this information and store it in an environment that allows us to have, you know, a very large amount of flexibility with our data that's in a common database. When it's sitting out in a cloud environment, it really gives us a tremendous amount of flexibility to make adjustments, enhancements in real time. So with that being said, any questions?
Hi, Shahani Karivasan from TransCanada. How do you put your threats together? Like, how do you combine the corrosion versus the mechanical damage and all the 9 threats?
Well, each of the 9 threats has their own individual defined logic on how they're evaluated. So in the end, when we look at interactions between those threats, we're defining a set of criteria to understand that if we have this one particular threat that's present at a certain magnitude and the presence of other kind of aggravating other factors, then we programmatically will elevate those risks and flag those areas to understand when there's the potential for interactions going on that we need to make an adjustment for. So it's really defined in the programming of the algorithm itself. I'm not sure if that's exactly what you were asking, but. Well, we do that just basically through a total risk evaluation. So we have weighting factors very, very similar to, I imagine, most operators. There's weighting factors for each of the 9 integrity threats, which all contribute to a total risk score. So, you know, we can pull out the risk score evaluations, if you will, for external corrosion threats for all of our dynamic segments of pipe, and they can be, you know, relatively ranked against each other. So that's how we would do that. And we do have business needs on why we do that, using our risk information to prioritize activities across the entire pipeline system. So not just really HCA focused. So when we have system-wide evaluations like performing close interval surveys across, many thousand miles of pipe, we use risk information to prioritize which one of those areas we should be looking at first. So we can, since the risk information is stored in a table in our pod system, we can kind of use that and overlay it with any other data needing to make, either IMP-related analysis or business-related analysis.
Hi, Chris Foley, Phillips Pipeline. Can you speak for a minute or two about your human infrastructure that you use to support company-wide risk? Do you have a central group of risk engineers? Are you spread out across the training you do? How you got that culture across your company?
Yeah, I mean, right now, we're primarily the technical work on feeding the risk model, maintaining the information in the GIS system. Those are typically centrally located, but we work very closely with people out in field operations that actually do the data gathering when we have either new construction work going on or just day-to-day maintenance. We're trying to put tools in place that allow them to leverage technology, if you will, so that they're able to fill information out electronically, submit it back to the core group that maintains GIS information, and just import that information in. But we're probably, if you're looking for central versus decentralized, we're probably more centralized with obviously the data collection portion happening out in the field. So it's a challenge. I think I can hear from your question to feed this much information into a system this size. It takes a lot of resources.
Yeah, I'm Khalid for GTI, Gas Technology. Just a question about, or a comment actually. When you identified your drip model and you said preventable, I would just question how you would call it preventable. Especially a hydrostatic test, it does not necessarily prevent corrosion.
No doubt.
So it's not really the direction that you want to go for to address the corrosion. Yes, it can be a factor, but my question is, I think most of your analysis is based on subject matter expertise to give risk scores. Is that correct?
It's all driven by hard data. So whether
Yeah.
it's a pipe coating type, whether it's a hard verifiable record on pipe age or manufacturer, it's
Yeah, but for example, external corrosion is time-dependent threat, and you will need to implement that as well. So when you said that you are preventing it by hydrostatic test, how do you score that?
Yeah, it's just one variable. There are numerous preventers that could go on, for that threat. So there's
I would call it something else.
sure point taken. I understand. It's not trying to imply that the threat of external corrosion failure has prevented just because a hydrostatic test is there. It's just another piece of information used to come up with the total risk.
Thank you. I think that's all the time we have
All right.
for questions.
Thank you all.
Thank you, Chair.